In this example, we're asked to write the repeating decimal, 10.135 repeating, as a ratio of integers, and we're given the hint to use a geometric series to help us do that. So let's start by writing out the repeating decimal and seeing if we can break it down into some more simpler terms. But this decimal is going to be 10.1, 35, 35, 35, 35, etc. So that's the repeating part. And then we can just kind of chop this number up and break this into a sum of decimals, which separate out the repeating parts. So in other words, we can write this number as 10.1 plus, the next term to get this to add up correctly is going to be 0.035, plus the next one will be 0.00035, and then plus 0. And now 5 leading zeros, 35, etc. And so now we've written this repeating decimal as a sum of decimals, and these last, at least beyond the first term, all the terms of the sum after the first term have a common factor and a very similar form. So what we'll do next is try to factor these out and write these as a fraction. Remember, we're trying to write this as a ratio of integers, so that means a fraction. So our first term, this is going to be 101 over 100, if we want to write that as a fraction. That gets rid of the decimal there. Plus, from these next terms, we can write each of these as a fraction. Again, I'll put these brackets here because these things are all common in some way. The first one is 35 over 10 to the third power, 3 decimal places. The next one is going to be 35, so plus 35 over 10 to the fifth, plus 35, the next term is over 10 to the seventh, etc. And we see exactly what the pattern is now. As we move from one term to the next, the 35 remains in the numerator, and we multiply by a power of 10 to the power 2, so 10 to the power 2 on the denominator. So that's going to be our common ratio, 10 to the power 2. So let's work this out a little more and see what we have here. Number one, we can factor out, there's a common factor of 35 over 10 to the power 3 in each of these terms that can be factored out of this sum over here. And what remains then is the following sum. So 1, we took that away. So 1 plus, this one's got 1 over 10 to the 2. The next one's 1 over 10 to the power 4. 1 over 10 to the power 6, etc. And here we see that this sum right here, this is a geometric series whose leading term is 1, and the common ratio is 1 over 10 squared, or 1 over 100. And so we can now write this entire thing in sigma notation. So our sum is, our number, 10.135 repeating, is 101 over 100 plus 35 over 1,000. So we'll write all this out in terms of, we'll expand out the powers of 10, times, now we have our sigma notation. This can be written as n to the power 0, n equals 0 to infinity of 1 times 1 over 100 to the power n. Okay? This is, of course, a geometric series. Geometric series with the a naught equal to 1, or a equal to 1, and r is equal to 1 over 100. 1 over 100 is less than 1, and so we know that this series converges, which, you know, it gave us, we started with a number, so we already had hoped that it would be convergent. But from our formula, we know that it converges to this ratio, a naught over 1 minus r. And of course, a naught is 1, so this is 1 over 1 minus 1/100th. And this simplifies to be 100 over 99, or 1 over 99 over 100, by doing the subtraction here. So let's put it all together then. What we end up with is 101 over 100 plus 35 over 1,000 times 100 over 99. And at this point I'm going to cancel some things, but I'm only going to cancel one of these zeros because I have a 100 here. And so we want to try to add this up to get a single fraction. We have to multiply this part straight across, so this one is going to be 101 over 100 plus, this is 350 over 9,900. Okay, and then to add these together we need common denominator, so we need to multiply this by 99. So we end up with 99 times 101 plus 350 over 9,900. 9900. And, of course, 99 times 101 is just, that's a difference of squares. It's 100 squared minus 1. So 100 squared is 1 with 4 zeros. So this is going to be 9999 plus 350 over 9900, 349. So add 350 to 9,999. You end up with 10,349 over 9900.